Pilots use aviation weather observations and forecasts on a daily basis. They help us decide whether we're going to go or not go. Do we need an alternate? How much fuel do we need to bring? But where do these observations and forecasts actually come from? I've invited Jason from the National Weather Service to help us explore that question so we can all learn more about these critical pilot tools.
All right. Well, good morning, everyone. My name is Jason Anglin. I'm with the National Weather Service in Bismarck. And also joining us today, I believe it's John Paul Martin. He's also here with the National Weather Service in Bismarck. And today we're going to kind of talk to you about we're going to kind of do a little different angle on things today. We're going to just kind of go through who is the National Weather Service. We're also going to discuss, we're going to go kind of through the whole TAF process, and then we have built in some time at the end to take your questions. So these could be anything from this presentation or anything you've always wanted to ask a live National Weather Service meteorologist. So feel free to write those down and be ready to ask them at the end here. But again, my name is Jason. I'm one of the newer lead forecasters here, lead meteorologists here in Bismarck. So I've been here since August, and I've already taken over the aviation program here, and mainly because the guy doing it, who did a really great job, he retired, and they needed somebody with some interests. And I've always had an interest in aviation. I went to UND, and then I've been in Riverton and Great Falls, and at both those places I've kind of done quite a bit with the aviation program. So John Paul Martin, he is our warning coordination meteorologist. So he leads the service side of our office, and so he is also a great asset to have on our talk today, because he can kind of plug in some things that he's seen on service wise, and he's also been with the office for quite a while, so he's seen it all, as they say, or as he will say. So this is our objectives today. So I'll give you kind of a brief, what's the National Weather Service? We'll do a virtual tour. We wish we could have everybody walk around the office and touch things and look at everything, but we'll do it virtually today. And then, like I said, we'll dive into the TAF process. We'll also talk about a little bit briefly about ASOS and AWOSs. I know sometimes we even get confused on them, so I figured we'll kind of set the record straight on those. And then I'll also show you, for the pilots, the dispatchers, for anyone really in the aviation community, there's some other great resources that are part of the NOAA community, so that we'll talk about. And then again, those questions, write those down. We're really looking forward to any of the questions you guys have today. So we'll jump right into it. So we are part of the National Weather Service, which is a branch of the NOAA, which is the National Organization of the Advancement of Acronyms. Oh wait, no, that's the National Oceanic and Atmospheric Administration. So, which is all part of the Department of Commerce. So there won't be a quiz on that, so there's no need to worry about that. But what you need to know is that we are here at the Bismarck office. We're considered the local experts in weather and hydro services. North Dakota has two offices that serve it. We have Bismarck and Grand Forks. We're open 24/7, so
hey,
nights, weekends, holidays. Yep. Yes.
If I could, go ahead and turn your video off, because you're having some lag issues and I don't want to lose you here.
Yeah, sure. Okay, stop. Which is that's the National Oceanic and Commerce. So there won't be a quiz on that. So we are here at the Bismarck Hydro Services. We're open 24/7. So okay, stopping the video there. How's that?
That's good.
Awesome. All right. So yeah, we're one of 122 offices staffed around the clock every day. We have a staff of, each office has a staff of about 20 to 25, so that includes roughly 15 meteorologists, and then we have four management positions actually, and we have the meteorologist in charge. We have the WCM, which is John Paul Martin's position. We also have a science officer, that is staffed by Chauncey, and then we have a technician manager, and then we have two tech, or anything really. We also have a kind of a information technology officer. He also keeps things going. And then we have a service hydrologist. So the important thing to note about the National Weather Service offices is we are responsible for all the watches, the warnings, advisories, anything you see like that on the news and stuff like that, that is the sole responsibility of a National Weather Service forecast office. And then for the aviation side, we're responsible for issuing all the terminal aerodrome forecasts. All the TAFs come from your local National Weather Service office. And we also kind of maintain data and climate observations. That's another key important fact of Weather Service office. So for the aviation side, though, there are other kind of regional and national entities of the National Weather Service. So I'm not sure how many people have heard of a CWSU, which stands for a Center Weather Service Unit. What's unique about CWSUs is they're co-located with air route traffic control centers. So they are on the ground floor with the FAA controllers there. They're briefing them multiple times a day, and they're available for people to come up and ask them questions, the meteorologist questions, at any time during their shift. So it's a very unique kind of partnership that these meteorologists have with their FAA counterparts, and it's really one of the more successful things in the National Weather Service. Other than kind of the warning services part, is that these branches are co-located. And they will issue at the bottom there you see they issue center weather advisories and meteorological impact statements. These are mainly for those ART, those air traffic controllers. They're kind of used. They're kind of a heads up for them, and then they kind of take that information and give it a heads up to pilots flying in their airspace. You'll kind of notice on the map that most of North Dakota is covered by the Minneapolis Center, but there is a branch, a little sliver there in the west, kind of the Williston southward, that is covered by the Salt Lake Center. So you can kind of see that there. Another big entity in the aviation community that is also part of the National Weather Service is the Aviation Weather Center, and maybe many of you are familiar with this because there's a lot of information on their website, and they're responsible for AirMets and SIGMETs. So, the AirMets kind of advise of weather that could be hazardous, so such as IFR, that's AirMet Sierra, turbulence is AirMet Tango, and icing AirMet Zulu. And then a SIGMET is a little bit more significant weather. So that's most of the time that's going to be your severe turbulence or your convection activity. Also, dust and sandstorms. So I really encourage you, and we'll kind of talk about this a little later, to check out their website. And we'll show that a little bit. But they're located in Kansas City, Missouri, and they're really responsible for the world airspace. They do all kinds of world products as well as the CONUS here. All right, so we'll kind of fly on back to our Weather Service office here. So we'll do a quick little tour inside here. And again, we wish we could have everyone just come and walk around, take pictures, ask questions, but this will be the closest thing we can do to it right now. So we're located by the airport in Bismarck. We are a upper air site, which we'll talk about. Of those 122 offices, only about half of them are doing upper air, which means we launch weather balloons. And so we're the only ones in North Dakota that do that, but there is some in Aberdeen, Rapid City, and Glasgow that are nearby. So this is the walk-in. You'll see we have a front desk here. There's a nice conference room back here. Where this sign is, that's our hallway into the ops area. Off to the left of the ops area, which I'll show in a little bit, this is our server room. One thing to note is this is probably one of the cleanest server rooms that I've ever seen, being in 3 offices now. And so our techs really take pride, and you always want that in a good tech crew, is that they take pride in their work and keep things nice and well organized. So here's more of the inside. So if we went down the hallway and just took a really quick right, this is our operations area, and you can kind of see it on the upper left there. We have about, I believe, 6 or so workstations, we call them. At each workstation, here's kind of an example, the bottom 2 pictures. So this is what we call our AWIPs, which, that just basically translates, this is how we create the forecast, review model data, and this is where we can send out washes and warnings. We also have a 2-screen PC on each desk, and this is where we can monitor our products, We have a NWS chat, we call it, where we monitor reports coming in, any questions from our partners. Really anything you need a PC for, that's where we use that. Up on the top here, the top right, we call this the situational awareness display, which is the acronym for that is SAD. So it's a little bit of a sad acronym, but this is really important though because it kind of keeps us updated on what's going on. Oh, and sorry about there we go. So you can see so really you walk in and I mean the first thing that I remember when I walked into a weather service office is just the amount of computers and displays that are in there. It's quite overwhelming almost at first, but it's really cool to see. So stepping outside here, we on the upper left here is our kind of our observation area. Remember, that's one of the key functions of a National Weather Service operation is to maintain observations. And so this is our snowboard here. We haven't gotten to use that much this year, unfortunately or fortunately, depending if you like snow. It would be nice to get moisture though. Speaking of moisture, this is our kind of our little rain gauge in there. So we use that to measure anything that comes by. And there is a gauge at the airport. This kind of helps us compare the two. You'll see a satellite dish. Off in the distance is the radar. So that's that little golf ball looking thing. That's our weather radar. And you can see even though there is a picture of the inside, don't tell John Paul I climbed up there and took a picture. That would probably get me in some hot water. But there it is. There's a picture there. So it's really big, but one thing that and it's kind of tough to see in this picture, it's really nice and confined in that radome. There isn't a lot of extra space in there, so it's quite big. And the upper right here this is actually an ozone observatory. We take ozone measurements 1 to 2 times a day. And then over here is on the bottom left is the upper air dome. On the top is an antenna that tracks we call it the radio son. It's the instrument package we set up. And inside is where we store all the fuel for the balloon. And so here's kind of on the upper left is the actual inside picture of Bismarck. The other pictures I took from my time in Great Falls. You'll notice even on the outside and the inside of the building, there's a lot of danger signs. That's because we use hydrogen to fill up our balloons. And in case you have ever seen that little video clip of the Hindenburg, they also used hydrogen to fill up their balloons. And so it's a pretty dangerous process if you're not careful. You'll notice there's no air conditioning or heater units in these. So the person that gets to go outside this last February was a little bit cold when they were out there. So but it's just for safety. And these balloons, they get about 6 feet when they're inflated. As they go up, they expand because we get less pressure as we go up. And they'll expand about 30 feet or so before they pop. And they go to about 100,000 feet when they do burst. And so they go quite high. This is an example of an instrument package here, radio son. Each radio son will have a GPS in it, so we can calculate where it is, but that also calculates wind speed and direction. It has a precipitation, temperature, and kind of a humidity sensor. So all those parameters are sent back to us, and we upload them to the National Archives, and that is used to create our weather models, but also used for us to get a kind of a good picture of what's going on in the atmosphere, especially during the convective season. These are very useful tools, but this is used every day for the weather models, twice a day. So at this time of year, we're launching about 5 a.m. and p.m., but that'll roll up an hour. So what does the launch look like? Well, this is one that we took from Glasgow here. Launches are usually pretty tame until you get winds. So let's take a look at this. So this was a high wind launch. So here we go. Let's get it out in that wind and let it go. Oh, all right, let's try again. Take 2. Here we go. Yeah. All right, success. Oh, no. Oh. That's called a double doink there launch. So we'll watch that one more time. So most, like I said, most launches are pretty carefree. The high wind ones are the fun ones. And the key is to get it kind of in the wind stream, not burst the balloon, and get it in the air. But it's, so that one, you kind of see the balloon kind of doing a little funny thing after you released it. So you kind of got in the eddy of that building and pushed it down. So we do allow people to come out and watch balloons. So if you're ever in the area during the balloon launch, you can always give us a call and see when we're doing them. Just come on out, and we even have people just park on the highway and watch them. So they're actually kind of fun to watch. So that's kind of all we have on our tour. Now we'll transition to how do we actually make the TAFs. But before we kind of talk about that process, we'll get into a little bit of kind of the direction the Weather Service is going with the TAFs. Maybe some of you have heard of Digital Aviation Services, DAS. It's relatively new. It was kind of out invented on the East Coast. They needed a way. One of the bigger complaints of at least of the FAA community and the pilot community is that you'd see a TAF, then you'd go to our actual forecast, and they didn't match. They weren't matching, which just really wasn't doing a good service for our customers. So we came with Digital Aviation Services. So what does that mean? So that means we're taking our forecasts, using a set of smart tools to create a first guess on the TAFs. And what does that mean for the aviation customers? That means that everything will kind of be consistent, and you'll get a lot more information out of it than you normally would. It does not mean, though, that this is an automated process. Yes, it does spit out a first guess of the TAF, but that is by no means the final TAF. So why do this? Well, it'll produce two new forecast elements. I'm not sure. One thing we didn't talk about is on our website, we do have it's called the digital forecast database, and what that shows off is some maps of our forecasts, and two new maps that'll eventually come are ceilings and visibility. So you'll be able to one day go in there and look at the forecast ceiling and look at the forecast visibility. That is to become soon, but it's going to be just more than that. It's going to benefit so many different programs in aviation and other things, and it'll kind of help with the increasing demand of aviation, especially once it gets ramped back up here. There's so many different customers that this serves as well. The FAA, think about if they want to go look at that visibility forecast, they'll eventually be able to pull it up. General aviation, we only really do TAFs for our big ASOS sites, but what about those other smaller sites that you may fly into? Eventually, maybe this will support that. Emergency services, think about a hazmat incident or even a wildfire incident that may have some air operations. With the DAS, we could easily create a TAF for those areas. And the NTSB, where they could use all of our forecasts are archived into a database, and for investigative purposes, they could go back and use these products to look at what the weather parameters were for a given incident. So really, that's the big push to go to DAS. So now let's kind of dive into the whole TAF process here. So TAFs are made for takeoff and landing. There are surface forecasts for takeoff and landing. So if you want to look at the weather for what you're going to encounter in between takeoff and landing, that's where you would go to, say, a CWSU or that Aviation Weather Center site. All our TAFs in North Dakota are 24 hours. Some say you go to Minneapolis or Salt Lake City, those are 30-hour TAFs. They're supposed to represent the 5-mile radius around the center of the airfield. They're issued every 6 hours in North Dakota. Some of those bigger 30-hour sites, again, Minneapolis and such, they're going to be every 3 hours. And they're amended as necessary. And keep in mind, those amendments are not necessarily just for the weather. They're more amended for, there's certain criteria. So they're more amended for, say, like a VFR versus an IFR condition. So category amendments And there are some wind parameters as well. And just to kind of very quickly, we'll go over the format of the TAF. So your first line is the date. It's the issue time. So 18Z to 18Z would be in this example. It's always followed up by wind. So if you have a G, that means gusting. It's the direction the wind is coming from there. So this would be kind of a southwest wind. Visibility, if it's 10 miles, you would see a P6SM. If it's lower than that, though, then you'll have a reason. So this is a shower, there's a thunderstorm. Anytime you have a TS, you're going to see a CB, and then your cloud coverage and your cloud height is going to be in a TAF. So, yeah, so that's just kind of what each TAF will look like. And typically these are 4 to 6 lines. Sometimes they're less, sometimes they're only 1 or 2 lines, depending on the weather that day. So how does a meteorologist at the National Weather Service go about making a TAF? Well, that's what we'll kind of dive into next. So first, we'll kind of, every time we come in and shift, we're going to be analyzing all the observations. We'll take a look. We have really good satellite coverage right now with our new GOES satellites. Radar, you saw the Bismarck radar. We also we get access to the Minot Air Force Base weather radar up there. So we have pretty good radar coverage actually in the state of North Dakota, because there's one in Grand Forks, kind of near Mayville, and then there's also the state actually runs a couple as well. So we have really good radar coverage in the state of North Dakota, except for maybe portions of the southwest and the northwest there. That's where we're still kind of lacking. So then we'll review model data. Again, remember we launched those weather balloons twice a day. This is kind of where that data goes. This is one model run here of what could happen. These are all potential. What's overlaid is precipitation. We have kind of like the upper air chart there. So we'll review that. So next we'll prepare that aviation forecast by editing data. So this is our graphical forecast editor, also known as GFE. And so any parameter you see here, there's wind gusts, there's skies, there's probability of precipitation, weather. Anything we can manually edit, or we can use a set of smart tools to edit. Right now, what I've shown here is our ceiling heights, and you see that most of our ceilings, when you see it's -30, that just means like sky clear. But looks like in this example, there's, so that'd be a 10,000 foot, and as you go further east there, you're lowering down to 3,700 feet or so. So we can edit all these parameters. There's wind gusts, anything on here we edit based on what we're seeing that day. Here is an example of one of those smart tools. This is called Aviation Populate. So what this would do is it would automatically populate. You select a model, and it would populate all this data, and then we can go and basically like we're in where you just kind of draw it. We'll click it and start drawing around with our mouse. We have all kinds of different tools to also help us. Once we have the forecast kind of where we want it, we'll run another smart tool called Aviation Finalize. And what that does is it just double checks everything. Make sure our winds and wind gusts are aligned, and make sure, if we have fog in there, make sure it puts the visibility down to say a mile or so, making sure that everything makes sense. And then once that'll spit out the first guess of the TAF. So here's our TAF editor here. So this, so that could be perceived as an automated TAF, but it is not. We're now instructed to go through and make sure these all meteorologically make sense. And how we do that is we go back to those models. We also will use our own sounding. This is an example of a sounding from Bismarck here. This actually occurred before we had all that fog in the area, and you can see why we had the fog. So the red is temperature, the green is dew point, and when those are close together like they are here, that implies that it's almost saturated, that's going to make a cloud basically. And you see on all these barbs here, these are wind barbs over here. So you can see in this lower layer of the atmosphere, very moist and very light winds, and that's what led to the fog. And so if I were doing the TAFs this day, I would make sure I had some fog in the TAF. And so then you double check them all for accuracy. You run syntax, which double checks to make sure we have the correct format. And you would go and send them out. Usually, so if it's an 18Z TAF, we would send that out anywhere from 1720 to 1740Z typically. And then this right here is our monitor. So green means good, yellow means you might be off a category. It goes all, the darker the color, the worse it is. So if you see reds and purples on here, that usually means you need to start thinking about amending a TAF. All right, once that's the process. Then you monitor for accuracy, amend as needed. And remember, most of those amendments are going to be categorical amendments or wind amendments. And of course, wait for good compliments. And sometimes, they just come pouring in, of course, or we're usually waiting a while. But days like today usually get a lot of good compliments, right? So that's kind of the whole TAF process there. So yeah, it can be, we have those really smart tools that gets us that first guess now, keep it consistent, but we still use our local knowledge to make them the best TAF we can. So let's kind of jump forward. Remember, we're going to quickly touch on AWAS versus ASOS. So here's a map of different sites across the state of North Dakota. You'll see these kind of grayish markers. Those are all our ASOS sites. So these are all going to be, most of these sites have a TAF for them. I see Hettinger, and I think Garrison up here, which is not marked. Those do not have TAFs, but the rest of these will have a TAF site for them. But the blues are the AWASs. The blues and some of these other colors. Most of the AWASs around here looks like they're blue, which is an AWAS type 3. And so what that gets you is, it gets you data plus cloud and ceiling. A 3P gives you data plus precipitation type. So just kind of note that not all of these sites are equal, and most of them are going to give you your simple wind data and temperature data, but they're, sometimes the precipitation data you won't see. You might see the visibility lower if you're an AWAS 2, but you wouldn't see like what the weather type was. So, and then kind of going into the ASOS part. So the AWASs are serviced by the FAA, where the ASOSs are a combination of the National Weather Service and Department of Defense. So they're probably a little bit more maintained than your AWASs. But if one goes out, they'll definitely do what they can to get anything up. And that's where you're going to get, the ASOS is where you're going to get a lot more service out of them, basically. You're going to get a lot more things from. They're like the all-inclusive. So you have wind direction, wind speed, ambient air, dew point temperature, ceiling heights, precipitation types, visibility, cloud heights, air pressure, all kinds of stuff, presence of lightning if that's equipped. So you're gonna see a lot more details from them. Not all the ASOSs are created equal. Some don't have those presence of lightning sensors. Some of the precipitation sensors are different. Some have a heated precipitation bucket where others don't. So there's still some minor subtleties with them, but you're going to get a lot more data out of them. One other kind of important thing to note, and maybe some of you have already noticed this flying around North Dakota, is that some of the sites have paid weather observers, or their FAA towers are augmenting the observations. So that is important to note, though, that the National Weather Service cannot augment METAR. We have direct links to most of them. In the Bismarck office, we can see exactly what's going on all the time at the Bismarck airport, but we cannot augment it. That's strictly an FAA program, and it's kind of becoming thinner and thinner. But Grand Forks does still have a paid weather observer, and I think maybe Fargo either has a paid weather observer or their tower is augmenting them. So, where the challenge comes in is when a site goes down, and unless there's an FAA tower there, that site will stay down until it gets fixed. And so, kind of something to keep in mind that we definitely try our best, especially when the ASOSs go down, to get them fixed as quickly as possible. But there could be outages for those sites that don't have weather observers. And Another kind of important thing to note in the ASOS world is Williston has a new airport, pretty recent airport. That airport location, though, is 500 feet higher than the previous location. So what this does, we've noticed just in the short time that's been open, is it gives higher winds and lower ceilings. You know, think you're 500 feet higher up into a low stratus deck, you're going to have lower ceilings, and just that little elevation also increases the wind. So for anyone flying into Williston, you might want to kind of keep that in mind, that it could be a little gustier and a little lower ceilings on those poor weather days. So other resources to consider. This is our website here, just weather.gov/Bismarck. You can find a wealth of information. One important thing in the aviation world is, did you know that every aviation TAF set we do, we also issue an aviation forecast discussion? And I'll show you how to find that. You just hover over forecast, hit forecast discussion there, and it's going to bring up our whole forecast discussion. If you scroll to the bottom, you'll see this little aviation part of it. So every TAF, so every 6 hours, this is going to be updated. So there's just only so much you can convey in a 4 to 6 line TAF. And so this is going to kind of talk about why something's placed in there, the confidence of something placed or even not placed in there, and just some other things. You know, sometimes we might make reference to turbulence, a low level wind shear you might see in a TAF, and so that could be placed in there. The fog, you know, a lot of times we can see that the ceilings are going to lower, but we're not 100% confident on the fog, and we might just write that, you know, fog, the confidence low, but fog possible. So really, if you're looking at a TAF, this should probably also be looked as well to kind of help you analyze what the true meteorological conditions are or could be out there. And we talked about the Aviation Weather Center. This is their website, aviationweather.gov. There's a whole bunch of information, METARs. They have a really cool TAF board. You can add a whole bunch of different TAFs. So if you're flying, you know, if you're doing a cross-country trek and you want to kind of gauge what the weather is going to be as you're flying, you can add multiple TAFs onto one site here and kind of visually see that. It's really cool. The air and PIREP, so pilot reports are very important in the aviation weather community. So highly encourage, if you encounter any kind of icing, turbulence, really any adverse weather, to submit a pilot report. Then your SIGMETs and AirMETs are going to be there. You can also find that forecast discussion here. And how you do that is you hover over forecast, aviation forecast discussion. And here, every WFO's Weather Forecast Office forecast discussion is here, right in a nice, conveniently located area. Keep in mind, these are written at the Weather Forecast Office that you click on, but they're also available on the Aviation Weather Center. So and also another great way to find that discussion amongst all the other tools that are there. And then, of course, we talked about the CWSUs. Here's the link for those. For the Minneapolis, that's ZMP. And then we have ZLC for Salt Lake Center. You can see the split there. So Williston area, that would pretty much Williston to Bowman West would be in Salt Lake Center. And this is, you know, although these are co-located with FAA, there's still a lot of great information on these sites. The Minneapolis Center here does these graphics every day where they kind of do like a little icing, turbulence, and low-level turbulence graphic every day. So really encourage you to check all these sites out just to see what you can find and kind of bookmark some of your favorite things. Another great site will be coming up here pretty soon on the convective season, the Storm Prediction Center. So these are just a bunch of severe weather experts to sit in a room, talk severe weather, or they'll just get ramped up about severe weather. They also do fire weather forecasts as well. And so these outlooks are just great to view each day. And it's kind of tough to see, but this color-coded scale here, that's their tier scale. So on this particular day, it was just a marginal risk. But a lot of times in the summer here, you're going to see yellows for slight risk. We do get enhanced, and Moderates and high are pretty rare, but they do occur around our parts, and especially occur in the southern plains here. So that's really, these are like a kind of a catch-all. It tells us where the severe weather threat is for the day, but also think about how that could be used for your flight planning. Say that we had a big red or purple bullseye over here in the middle of North Dakota. Well, then probably want to maybe reconsider my flight plans for the day. Or if your plane is parked out on the tarmac there, you maybe want to see if you can rent a hangar for the day, because we do get some very large hail. And when you click on these, if you go to convective outlooks, they do break it down based on hail, wind, and tornado threats for the day. And so very important to go and check those daily, especially as we start getting into the convective season. And they'll even write a little aviation blurb in there when they issue these. And also important to note is the Storm Prediction Center issues all the convective severe watches. So severe thunderstorm watches and tornado watches. Those are they are collaborated with us here in Bismarck, but they will all start there, and they usually put a little aviation section in those as well. So another really good resource to use. All right, well, as promised, we left some time for some questions. This is our public number. Please call us anytime, but we will take your questions now. And I will say, though, thank you. Just a quick thank you for having us. If you enjoyed us, and we want to be a real integral part of the aviation community. So we'd be happy to talk at any event, or even just if you have a little kind of pilot meeting that you want us to talk to. Really, we just want to get to know what your needs are and work with everyone here. So this is really pleased to be on this. So I will stop here now, and we will take any questions that you have.
All right, Jason, we currently do not have any questions. Did John have anything he'd like to add?
Hopefully, can you hear me okay?
Yes.
Oh, okay, great, thanks. Yeah, sorry, I was about 3 minutes after 10 that I got onto the call. I had, of course, I made the mistake of checking my audio when I tried to get onto the meeting, and it got caught in a loop, and I had to come out and restart. But no, I don't. Just again to reemphasize what Jason said. A pilot ever in Bismarck and would like to come in for a tour of the office, we'd love to have you, of course. Right now, we can't do that with COVID. We're under restrictions where no one's allowed in the office other than the forecast staff. So, but once that breaks, if you're interested to meet the forecaster and see how the TAFs are made and all the equipment we use and have, I think it'd be a big thrill for any pilot who hasn't been in. And if you have been in a weather office, it'd be a re-thrill for you. I'm sure you had a good time there. So know that we're here to serve you. And we'd like to establish a strong relationship. You're a very critical part of our customer base, aviation is. So thanks so much for the opportunity for Jason to talk with you today.
All right, it looks like we do have a question. Give me 1 second. All right, we have a question. Is there a good way to forecast mountain wave?
Oh, that's an excellent question. So the Salt Lake Center, the CWSU there does some really good mountain wave type forecasting. But so basically, for those unfamiliar with mountain waves, that's when the air goes across the mountains, depending on the stability at the time. So stability means the availability for the air to go up or go down. So in a weekly or kind of a weekly stable atmosphere, it'll go up but then come back down. So how do you forecast something like that? Well, the first thing you need to kind of look at is the winds at mountaintop levels. So when I was in some of the western offices, we would look at kind of that 700 millibar wind. Anytime you had a really strong 700 millibar wind going across the mountains. So it also needs to be kind of right smack perpendicular into the mountains. So if you have a north-south orientated mountain, then a strong west wind would do it. And then you need to look at those stability kind of parameters. And, basically kind of these windy days that we've had out here, those are kind of the windy but yet clear days. Those are those days you really got to watch out for. You can definitely get some clear air mountain wave turbulence across that. So anytime you have a real strong wind coming across the mountain range, you almost just want to kind of prepare that it's going to be a little bit bumpy. And there are some cues. You see those lenticular clouds form, or sometimes you'll see a whole bunch of clouds and then all of a sudden a clearing hole near the mountains. That's also something you maybe want to avoid. But I would definitely recommend looking at that Salt Lake Center CWC for more information. But just kind of know that anytime you got a really strong wind at the mid to upper levels, you could get mountain wave turbulence. Excellent question.
Jason, what would be a stronger wind? What would be on the side of a stronger wind?
Excellent. Excellent question. Yeah, so really, any time you're in the 40 to 50 knot range, then you want to start considering that you're going to have some mountain wave turbulence, and sometimes it also depends on the winds above it. So you look at the 700 millibar or even the 500 millibar prognosis charts there, and so say you have a 50 knot wind at 700 and you're approaching about 70 knots up above there, so that can also do it. So really that 40 to 50 knot threshold, you want to really start considering a mountain wave turbulence as possible.
All right, we had one more question. Is your office responsible for model output statistics, reports, forecasts, and can you explain those versus a TAF?
Oh, excellent question. So the Weather Service community and the whole NOAA kind of community is kind of one. You really see it as one big team. So there is a bigger entity that is more responsible for hosting the model data, putting the model data together, and coming up with all that. But the Weather Service offices, their responsibility to that team is to provide feedback on that model data, and then to take those local observations, whether it's those upper air observations or just the observations we get from the airports and such, to feed into that model data. So that is so it's kind of one big team, but locally though, we're not really touching much of that model data. We're more using it to create forecasts, warnings, and such. Hopefully that answered the question. Maybe John has a few more things to add to that.
Yeah, what I would say is the local office, we release some of them, as Jason said, not all of them, but the local office, we release the weather balloons. We collect all the surface data from the ASOSs, AWOSs, and so on. All that data is sent off to, let's just say it's Silver Spring, Maryland, let's just say Washington, D.C. And these supercomputers run over all this data. And then, you put this information into a model and the model runs out. And it spits out not only graphics, right, that you could look at, but it also spits out what's called model output statistics, MOS. And that's a table of numbers, and they're coded. So a ceiling, on a certain guidance, a ceiling might be a 7, that means unlimited. A 6 is lower, 5, 4, 3, 2, 1, is like 200 feet or something like that. So we don't compose that data. That's kind of spits out after the model is run, but we utilize that data tremendously. And what we've noticed, over the years using that is, for example, this season would be a good one. If you look and look at temperature, for example, the model assumes when it spits out this model output statistics, these numbers, it assumes, for example, in January that there's snow on the ground in North Dakota, and it's probably pretty deep snow, right? Well, you notice over the years that, wait a minute, this year, the guidance is always too cold. It's forecasting a high of 10 today and we get to 20. It's forecasting 10 below tonight and we only get to 0 or something like that. The guidance is too cold. Well, we've come to learn that's because the assumption is that there's snow on the ground. And for example, this season, there wasn't snow on the ground. So we noticed some of that happens, So again, it could be assuming that snow is melting with the warmer temperatures. And so it would maybe introduce fog into the model output statistic. where in reality we don't get it because we don't have any snow to melt. So things like that go into it, and might affect, for example, the dew point on there, and then depending on the dew point temperature spread, the model would be expecting fog when in reality we're not getting it. So hopefully that helps a little bit too. So yeah, we use that guidance, but we don't compose that. We're a user, kind of just like you, a user of that data.
All right, and we had one more question here. Is there a good way to anticipate fog compared to dew?
Oh yeah, another excellent question. So there's definitely a different atmosphere kind of setups to produce fog. So anytime really you have you need light winds, because too much mixing will kind of scatter out that fog. You need your temperature and your dew point to be pretty close, if not the same readings. And so, going back to the question of how is that dew versus fog? Dew is more, your ground is cold, it's going to match kind of the temperature, whereas fog is your whole low level air column is low, and there's really light winds, and we get fog around here. We had it recently because we kind of went to that southerly flow, so that affected a little bit of moisture up into the area and increased our dew points, but yet we're clear and dry and cooling. So our temperature is cooled right to that dew point. A lot of times, going back to this time of year, we have snow, and when we have these nice days, that snow melts and kind of saturates that lower level of the atmosphere a little more. You can get fog pretty easily, but you really, just for fog, you just have to kind of know what's going on those low levels. And know that, if we have a lot of moisture lingering around and we have the temperatures cooling to that dew point and very little wind to mix it out, you're gonna get fog. And then sometimes we even see fog on the river because you have a really cold air mass, and then that warm kind of moist air from the rivers coming up. So just kind of have to know what's going on in the lower levels, and if it's pretty much saturated in that low level of the atmosphere, then you're going to get fog. But if it's really only confined to the ground, then you're just going to get dew. So hopefully that helped out.
All right, we had one final question. What is potential vorticity?
Yeah, see, let me back up 1 second on that with the fog and the dew. To the person who asked that question, if you ever figure it out for sure, please let us know, because be honest with you, there have been nights I've been working a shift and we're expecting fog, and here the moisture comes out of the air as dew, or in the colder temperatures, frost, right? And other mornings when you think, okay, we're going to wake up with a frost, you wake up and it's fog. So everything Jason said, of course, is correct. Just that sometimes, the atmosphere brings the fog you expect as dew or frost, and other times you expect frost and dew, and it brings it out in fog. So it's a tremendous challenge to know which one's going to happen when, and we haven't cracked that nut yet. So anybody who can help with us, I think, and I won't mention any specific names, but there's some significant carriers of products, say, let's get delivered to your house, and they have meteorologists working for them. You probably know who I might be thinking about. A couple of those certain carriers. Some have browner trucks, some have whiter trucks, and things like that. I won't mention their names, but they have meteorologists working for them, and they've done some studies on that, trying to determine, is it going to be fog or is it going to be a dew and frost, and they've had a little bit of success, but I don't think full success yet on that.
All right, I think that's it.
Was there one more about, I thought I heard you say vorticity or something.
Oh, yes. What is potential vorticity?
Yeah, something about vorticity, that bad word.
Yeah. So potential vorticity, probably the easiest way to explain it is, I know we're all big figure skater fans. We can't get enough of it. So think about the figure skater that's skating away, getting judged and watched by everybody. What happens when they start spinning? They have their arms out and then they pull them back in. They're spinning really tight, and they put them back out. That, in a way, in a very simple way, is vorticity. It's just kind of the measure of the spin of things, and so kind of relate that to a low pressure system spinning around, and say that low kind of goes up over a mountain, gets compacted, has a little friction on there, that you're compacting, and it's really going to spin, and then as it gets off into the plains, it's gonna do something different. And so the potential vorticity is just a way to kind of quantify that, and then also use that to kind of come up and predict of how a low pressure system is not only how it's going to act, but also how it's going to form and kind of react to its environment. So I'll see if JP has anything, or John has anything to add to that, but that's kind of how probably the easiest way to view that.
No, Jason, that's a much better explanation than I could have given. Much better.
All right.
All right, well, that's it. We have no more questions.
All right, these are excellent questions, and again, we'll reiterate what we said is thank you again for having us. Be happy to help out in any other way that anybody feels free, and call us too if anything comes up after this. But thanks again for having us.